Hello, Honors Chemistry, and welcome to 13.4, where we talk about gases as solutes in aqueous solutions, right? So, first of all, it is a strange notion, the concept of gases dissolving in water, right? You guys, again, in middle school, learned that water is polar, very, very polar, right? And that's part of what makes it a good solvent, right? A lot of gases, right? So here, pretty much everything discussed in the textbook, right, has to do with the dissolving of carbon dioxide in water, right? Note that carbon dioxide is nonpolar, right? Which is why getting it to dissolve in water is not easy, right? And it doesn't dissolve very well, all right? And so how much dissolves varies greatly, right? And so even if things aren't, going back to the phrasing in your book, like dissolves like, right? Even if things aren't polar like water, we can get them to dissolve, right? And there are certain conditions that we can employ to help them dissolve better, right? So for CO2 gas and for all gases, right, one of the things that we can do to help it dissolve better would be to increase the pressure, right? And to be specific, it means increasing the pressure, like in this picture, right, of the gas particles above the liquid, right? So if we compare these two, right, we'll see that here in the picture on the left, we have 1, 2, 3, 4, 5, 6, 7, 8 gas molecules in the space above the liquid floating around, right, applying pressure, where pressure is the force when that molecule runs into something, right? It applies a force, okay? And that's what we mean by pressure. So here, the picture on the right, we'll see that there are more molecules floating around in that space above the liquid, which means that more force and more pressure, right? And if we think about dissolving, what that really means is that a molecule needs to run into the water such that there is an opportunity for the water and that carbon dioxide molecule to interact such that that CO2 will dissolve in the water. Yes, right? So what we are doing by increasing the pressure really means we're increasing the number of particles present, which increases the opportunity for interaction, right? Which means that more of it is likely to dissolve, right? Which is why when we think about a soda, right, or any carbonated beverage, right, there is liquid and then there's that empty space at the top, right? So the next time you're at the store and you see all those plastic bottles where you can see through them, you can see there's that empty space at the top, and that's referred to as the head space, where we can charge the vessel with lots and lots of gas such that it is at high pressure, such that a bunch of it will stay dissolved, right? And then that's why when we open up our soda, right, like it is in this figure, once we open it up and we give gas more places to be, right, it will, escape, and we can hear that escaping every time we pop open a soda, yes, or a carbonated beverage. Yeah, does that make sense? Right? Which is also why, so this concept, right, of changing the solubility of gases in water, right, is part of the reason that, for example, the bubbliness of something might seem to change based on temperature, right? So, for example, the flavor of a soda is different when it's cold versus room temperature, right? Try that out and check next time, right? Try a warm one versus a cold one and see if you can taste the difference, right? So, again, your book says that increasing pressure will increase the solubility of a gas in the water, right? In addition, decreasing the temperature will increase the solubility of the gas in water. All right. This is Gases and Water. Thank you for listening. Be good, do your homework, and I will see you soon. Bye.